been applied in the power system. So basically kita ada this are the relays. We have overcurrent relays. You kan tahu kalau konsep overcurrent relays ni operating dia based on the pickup current. If the secondary current, second I prime lah kita katakan, over the pickup current ni of the CT. What happen is it will turn on the CT lah. It will turn on the ni lah contact of overcurrent relay ni. Okay. Whenever overcurrent relay contact turn on, what happen? Dia akan turn on breaker akan open lah in order to isolate the fault. Itu konsep of overcurrent relay based on the pickup current. Okay. Kat sini pun ada lah ada tak kat sini? Okay, this one I prime must be greater than IP, pickup current. Pickup current maksudnya minimum current to turn on the overcurrent relay. So function of CT ni dia cuma step down the primary current to the secondary. So the step down current from the CT ni, circuit I prime ni must be greater than the pickup current of OC in order to turn on the contact of overcurrent relay. Okay, itu satu. Right? Then we go to the directional relay. So nak balik lah. What's directional relay? Based on the forward and reverse operation. Because the directional means that they're operating in the forward bias atau forward direction of the current. So kita go to the directional. Okay, where is it? Okay, ini pun sama ini overcurrent, right? I skip this one. Overcurrent, still overcurrent. Okay, directional relay. Directional relay basically get configuration lah, tengok pada sini lah. Normally dia akan combine dengan overcurrent relay. So maksudnya it will operate on forward direction. Forward direction. And let's say fault at P1, because of the current go to the CT first, then baru dia pergi pada fault, so be considered as a forward direction. Kalau fault kat sini, dia jadi reverse. Sebab dia pergi pada fault dulu, later on baru dia pergi pada, so maksud it cannot be lah, it's a forward, it's a reverse direction. So only the fault at P1 will trigger on the directional relay kat sini. Itu konsep of directional relay. Simple. So you tengok kat sini lah. Okay. So this is trip region, means it shows that it operate the relay only on direction, one direction. Okay. So kat sini juga ada calculating for the torque. Torque ni sebenarnya konsep dia macam ni lah. Dia nak turn on the contact of direction relay tu, kita kena calculate the torque. Kemudian lah kat sini pun ada example question kat sini. Okay, the next one kita discuss about what? Kita balik kepada impedance relay. Impedance relay based on the impedance of the length impedance of the line, transmission line. So this one kita discuss. So dia ada we call it as a Z reach, impedance reach. So the fault impedance must be greater than the Z reach, ZR. Yang mana kalau I buka balik impedance. Okay. Ini directional, saya tak lagi anymore. Also protection, okay. Ini zone, okay, kita relay. So, this is what the mean of Z reach. So, trade region only in this circle, yellow circle, inside. Outside the block, maksudnya the impedance fault must be smaller than the Z reach. This one. Barulah the relay akan turn on. Right? Okay, and then in relay we have two types of the relays. We have the impedance relay with directional restraint, or we can use modified impedance relay. So what is the difference between these two? Modified, you can see here that the circle is offset above the R, zero axis. This one just a normal impedance relay. Okay, that's the difference. Then we talk about the zone of protection, zone 1, zone 2, zone 3. So the reach of each zones are different. For example, this one is 80% cover of the line 1. This one is 130% over the line 1. This one the highest within the network. So this one I dah discuss sebelum ni. This one right. So then we go to the last one is the direct differential relay. Differential relay basically it's used to protect protect the equipment such as generator, buses, power transformer and transmission line. Transmission line ni rarely jarang lah but it's focused on the equipment. Okay. So how the differential relay operate is based on the mismatch between the I1 prime and I2 prime. So concept dia simple. The primary winding. Kalau transformer ni, this is primary winding, this is the secondary winding. So the mismatch between this I1 prime is the secondary current for I1. I2 prime is the secondary current for I2. So the mismatch, ada tak different? Whenever there is a mismatch between the currents, so it will trigger the contact of the differential relay to turn on. Contact itu on, dia akan open the breaker. Okay, itu konsep dia. Okay, so that's are the type of relays that we cover on the chapter in this chapter protection. Okay, so today ada soalan tak before we start the tutorial? Semua okay kan? Tak apalah, rasa semua okay lah. Kalau tak apa, kalau nak tanya, dia tanya. Tak ada masalah. All this sekejap. Alright. Kau semua, you all dah open ke dia punya tutorial for overcurrent tu ada? Dah buka dah? Ada
Ada sir.
So dia ada satu lagi tak dapat nak share. Tak tahu kenapa dalam tak tahu boleh nak share dekat. Ada satu lagi lah differential. Saya tengah nak share tapi kemudian kalau tak boleh saya akan share after class. Tak apa, kita start on the overcurrent relay dulu Okay. So ada dua satu ialah overcurrent dan the other one is differential. Ini I tak dapat share dalam tu. I tak tahu kenapa ada problem WhatsApp tu. Later on saya akan share. Okay, kita focus on this one dulu. Okay. The schematic diagram of an overcurrent protection system to protect transmission line is shown in figure Q1. So this is figure Q1A. Okay, so you boleh open lah sambil tu you boleh post sendiri. The excitation curve for the current transformer is given in the figure Q1B. So you faham this is the excitation curve and this is the connection of relay overcurrent relay. So you nampak kat sini lah. Right? In your note pun sama if you back to the notes. So ini kita we call it as excitation curve. Relationship between secondary E prime and secondary excited current IE. Nak guna macam mana later on saya akan explain dalam ni pun ada kat sini saya ada explain sikit kat ini Okay. Kita nak cari mismatch CT errors mudah lah. Ni question for CT error. Okay. Alright. So ada dua slide yang boleh refer later on kalau you nak tengok tutorial ni. Slide number 14 and slide number 15. Okay, so back to the tutorial. Alright, not this one, the other one, this one. Okay, so these are the two diagrams representing the first one is the connection of CT and overcurrent. So what we have here, okay, basically there are three line the three phase, represent three phase. Okay, look at the contour ini phase A. We have one CT ratio connected with the overcurrent relay. Okay, kalau you look, if you look at the notes, sini pun ada lah. Ni ke? No. This one. This one overcurrent relay. Saya mana? Tadi. Tak tunjuk lah. Okay. Oh, it's okay. Tak apa konsep dia, cuma yang ni pun boleh pakai lah cuma different dalam in the tutorial figure dia tak ada distance, dia cuma ada overcurrent so we just because this tutorial on overcurrent, okay, konsep sama lah so it has the acceleration E, then dia ada ZB, terminating impedance, sometimes we call it as a burden burden impedance so leakage impedance I1 prime, I prime 6 ampere. Okay, so this is the DC supply, contact of the overcurrent relay, and this is the breaker coil. Kita ada konsep sama whenever this overcurrent relay, kat sini overcurrent relay, turns the I1 prime ataupun secondary current of CT ratio which is higher than the pickup of the overcurrent relay. So what happen, dia akan trigger, dia akan onkan contact of overcurrent relay. Itu yang berlaku kalau fault kat sini okay. If the fault happen, so ceritanya CT ni akan step down the current kepada I1 prime ataupun kat sini I prime lah, kat sini dia bagi dah 6 ampere. Okay, so look at the question apa soalan dia. Okay, states the 5 criteria considered in the power in the system protection design. B, discuss in detail the operation of protection system when fault occurs at location P1. So you kena discuss. Ini ini biasanya soalan-soalan macam dia. State ni kena beritahu lah 5 kriteria. Tak ada apa, ini just follow the note adalah kita boleh cari discuss in detail the operation of protection system. Okay, maksudnya apa akan berlaku? What happen kalau fault berlaku dekat P1? I cakap tadi of course dia kena tahu I1 prime. So we need to make sure that I1 prime is greater than the pickup current barulah the overcurrent relay akan turn on, trigger Okay, determine the secondary current voltage E prime, excitation current IE, and primary current IP, and CT ratio when ZB ZB is Z burden Z burden is 0.752. What is Z burden? Dalam nota pun ada cerita pasal Z burden kita letak kat sini. Letak overcurrent ni pun ada kat sini the total impedance terminating a device called burden ataupun impedance so kita akan guna equation ni lah later on in order to determine all the question kat sini lah. You need to determine the E prime, IE, CT ratio, percentage ratio, etc. by the using the value of ZB is 0.752 ohms. Will the overcurrent really operate when the fault current is, okay, now it's given, let's say the fault is 150 ampere. What happened to the overcurrent? Is it turn on or it trigger or not? So this is the question, okay, A, B, C. So we look at the question A dulu. State the 5 criteria. So 5 criteria you boleh, you can see here, right? Reliability, selectivity, economy, simplicity, speed, sensitivity. Apa maksud reliability? Operate dependently when fault condition occur, even after remaining idle for months or years. Kita boleh reliable, kita boleh depend on the atau kat sini kata work dependently dia boleh operating by itself lah, right? Okay, selectivity, avoid unnecessary false trip. So maksudnya it can choose, it can recognize the faults, dia tak turn on at the different false trip, tak nak kita focus on the, kalau let's say overcurrent relay, overcurrent protection, just focus on the overcurrent faults. Okay, kalau the differential faults, so it can choose. Economy, provide maximum protection at minimum cost. Of course, considering the price, economy, you can protect with the lower cost condition. Simplicity, minimize protection equipment and secondary. Speed, operating, try to operate at a high speed in order to minimize the damage to the equipment. So any intentional time delay should be persist. Some of the setting dia ada delay, tapi delay tu kena persist tepat lah. Okay. And the last one is sensitivity, able to distinguish the small difference between fault and normal condition. It's very important, sensitivity, because it needs to able to differentiate between the fault and the normal. Kalau tak boleh nak differentiate what happen, dia akan always state. So you tak boleh nak operate, system cannot operate because of the tripping of the breaker. Jadi it must sensitive, it have the sensitivity. Okay, question number 1. Question number 2, B, discuss in detail the operation of protection system when fault occurs at location P1. Okay, so what happen when fault occur here? Kalau you use one nota kan, you buka sambil tu sebab I kena scroll up and down tak boleh nak in one position. I kena scroll down, so you agak pening kalau you tengok kalau you tak buka your notes alright, P1. So what happen when fault at P1? Okay, alright, during the fault condition at P1, okay, the current transformer CT reduced the primary current from 150 amps to 7.5. Okay, itu akan berlaku. Kat sini dia cerita tak berapa fault. Okay, sekarang ni dia tak kira, dia tak bagi tahu untuk question B, tapi dia guna data from question C. Tak apalah Okay, kita boleh konsep yang sama Okay, what happen when the fault 150 amps kat sini fault kat sini 150 amp. So what happen is 150 amp will be stepped down by current transformer to the value of kena kira lah by referring to the CT ratio. So in this case, what happen is fault is 150 amps divided by the CT ratio, so we will have 7.5 amp. So maksudnya inilah step down current dan inilah I1 primary lah, 7.5 amp, which is suitable to the overcurrent protection relay. Alright, itulah because dia step down kepada this amount, this value. In the overcurrent protection relay, the secondary current I prime exceeds the specific value of pickup current IP, where is 7.5 amp is greater than 1P. IP is 6 ampere. So mana dapat 6 ampere? From the question. Question ni dibagi ni 6 ampere. Okay. Dalam ni dia tak mention tapi dia tak bagi tahu kan. Tapi kita tengok sini lah. Okay. Normal condition. You please consider as a peak current pickup current because without the fault suddenly dia ada value of I prime so must consider as a pickup current the minimum current required to trigger the overcurrent relay. So ceritanya 7.5 is greater than 1P, so what happen? This will energize the relay operating coil and cause the normal open contact to close. Whatever it will energize, you trigger, turn on the operating coil of current transformer. Overcurrent relay tadi. So dia akan close the contact ataupun contact dia akan close. This one normally open contact. Normally open ni maksudnya this is really open dia tak bersambung and then dia akan turn on whenever dia close, dia akan contact. So current akan flow through this contact dia boleh flow. Okay, because coil dia turn on. Okay. Alright, when the relay contact is closed, this will energize the circuit breaker trip coil and cause the circuit breakers CBs to open in order to isolate the fault from the healthy system. Okay, so what happen? Contact turn on, dia akan energize the coil of breaker ni. Breaker pun relay juga, dia ada coil So what happen? Dia akan open, breaker akan open, so dia akan isolate the faulty part ini faulty area fault from the healthy part ataupun equipment. So what that will happen when the fault occur at location P1. Okay. So we have 25 students. Okay, good. Alright, faham Okay, itu question B. Question C, determine the secondary current E prime, extension current IE, primary current IP and CT ratios when ZB is 0.752 ohms with the current relay operate when fault is 150 amp. Okay, so kita sekarang ni you nak kira all these element Okay, the first step you nak kira ialah kita determine the secondary E prime So E prime, macam ni question of E prime back to the nota kat sini, back to the notes E prime is Z Z prime plus ZB I prime. This equation kita gunakan later on untuk kira P prime. Okay. So, this one. Okay. Alright. Alright. So I prime given 6, ZB is 0.752 from this one. And CT ratio is okay, Z prime. Okay, adakah dia refer? Okay, Z prime is 0.082 and CT ratio is 100/5. Okay, mana dapat saya punya pusing dekat atas. Okay, this one this is the Z prime dalam soalan ni ada 0.082. Right? Okay, we have the Z burden because kita nak refer to this equation. So we have this Z prime and we have Z burden. Then we have I prime. So we can determine the E prime. Okay, right, this one Right. So we have this one from the question. This one from the, also from the question but from the figures kat atas tadi. So ratio from the questions, this one from the figures yang atas tadi. So from here we can determine the E prime. You just substitute into this Z prime, ZB, I prime. Okay, then we have the value of E prime is 5 volts. Okay, kenapa you nak kira ni? Sebenarnya you nak refer back to this ni kita panggil dia curve of secondary excited voltage E prime versus the secondary excited amps. Kita nak tahu ini Dan kita nak dapatkan nilai ni IE ni, secondary excited amps, because of yang ini kita nak cari nilai ni. Okay, kita go step by step. Mula first step we determine the E prime, later on kita nak determine the this component right. Tapi of course we need to know the IE excitation current from the curve. Okay, so for this question we need to determine the E prime. That's why kat sini you cari E prime. Okay, in this value is 5 volts. Okay, from the excitation of curve of CT, we can obtain the value of I3 is 0.3. So where is 5 volt? First kita tengok this is the ratio is 100/5. So di kat sini, okay, you tengok there's a lot of curve. There are many curve here. Dia ada 300/5, 100/5, 150. So kita ignore this one, all this. Kita cuma focus on our CT which is 100/5 kan? Okay. Kat sini dia bagi dah, okay, this one 100/5. So yang mana curve dia ialah, okay, I kena zoom in kan untuk nampak nanti. Okay. Alright. Dan ini 100/5. So yang lain tu not valid. We just focus on this curve. Okay. Alright. So what's the value of E prime tadi? Berapa tadi? 5 volt kan? 5 volt kan? So kita kira lah. Ini 1, 10. Dia punya scale 100. Maksudnya 1 ini kosong lah. 0.1, 0.2, 3, 4. Ataupun 0.3 macam ni. 2, 3, 4, 5, 6, 7, 10 lah. Sini 1. Jadi 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So dia akan intersect with this curve. Kat sinilah area dia. Okay. So 0.1, 0.2 dalam around 0.3. Kan nampak 0.3? Because dia intercept dengan 5 volts. So you dapat nilai dia IE or secondary excited amps is 0.3 amps. Kenapa nak kira ni? Back to this notes. You kena dapatkan nilai ni. This current from the curve. Okay. So this is 0.3 amps. Macam mana dapat tadi? Again, saya cerita sekali lagi. One more times. Because our CT is 100/5, so we focus on this curve, 100/5. Right? So from the calculation, E prime is 5 volts. So this is 5 volt. 1, 2, 3, 4, 5. 5 intercept here. So you dapat nilai 0.3. Lebih kurang lah 0.3, 0.2, 0. Okay, kat sini 0.3. Okay. Okay, now we have the value of excitation, current, i.e. 0.3. Okay. So now we can get the value of I primary. Question, this is I primary. Okay. So the calculation of I primary is you substitute into this equation. This is the ratio I prime, this one, plus the I excitation, dapat 1 to 6 ampere. Okay, soalan dia, will the overcurrent really operate when the fault current is 150? Dia operate ke tak? Okay. Okay. Then later on kita cari lagi. Okay, belum tu kita go to the city errors. Okay. Right. City errors, equation dia macam ni Ini equation dia. Sebab dalam soalan ni ialah you need also to determine the city errors. Okay. IE divided by I prime plus IE. Yeah. So from equation here, we can obtain the value of city error is 4.76%. Okay. Okay, by using Z burden 0.752, 126 ampere is the lowest primary current that cause relay to operate. Therefore, the relay will operate for the fault of 150 fault current. Okay, so we are complete. Okay, so faham sekarang ni fault dia ialah 150 ampere. From the calculation minimum, so maksudnya 150 ni higher than 1 to 6, so dia akan operate. If the lower than 1 to 6, contohnya you dapat contohnya fault kat sini dia bagi 120 amps, operate ke tak? Dia tak operate because the primary minimum pun 126. Faham so, tapi in this case, because 150, you get the I primary is 126, so it will turn on, it will trigger the overcurrent relay. So boleh faham sampai sini overcurrent relay? Okay ke? Okay, sir. I explain clear kan? You faham kan?
Clear.
Alright, good. Tak faham, kita tanya kemudian Okay, kita pergi pada second question Second question, tutorial on directional protection. So directional, you tahu they operate based on the forward direction Okay, kalau you baca nota kat sini, dia ceritalah the relationship between voltage and current. For example, this one ni. Forward direction, I lack the voltage. Reverse direction, I lead the voltage. So this is what happened in the direction, forward and reverse direction. Okay, this one. Okay, look at this questions. Okay, 9 dah. Ada lagi orang nak masuk? Tak ada kan? Okay. So we have 25 student. 5 orang tak datang kelas. Sayang Kalau you tak datang kelas, mungkin you nak faham susah agak benda ni kalau tanpa explanation you kena datang kelas sebab you nampak dia punya pictures, gambaran dia macam mana dia operate Okay. Alright, in figure Q2, this figures, you nampak figure ni. You pun pernah tengok figure ni, dia combination of directional relay and overcurrent relay. Dia ada contact. Cerita senang This one operate based on the pickup current. This one operating based on the direction of current, forward or reverse. It just need the forward direction. Okay. Alright. In figure Q2, the voltage transformer and current transformer are used to connect the directional relay in series with the overcurrent relay OC to phase A of transmission line. The system is operating at a frequency of 50 Hz and the overcurrent pickup current is 500 amps. Okay. So dia bagi dah pickup current untuk overcurrent 500 amps. So maksudnya cerita dia, the fault current must be greater ataupun the secondary current must be greater than the pickup current. Okay, untuk CT. Alright. So apa question dia? Explain in detail the theoretical concept operation for the directional relay D and overcurrent relay OC circuit when fault occur at P1 and P2. So cerita dia, this question gives you two conditions, P1 and P2. So what happened when P1 fault occur at P1, and what happened P2. So what happened to the relay? So fault kat sini, adakah both relay akan operate or this one? Alright, kita look at the solution by kita discuss lah kat sini, you faham. Okay, explain in detail the theoretical concept. Dia kata in detail. You jangan buat simple in detail. Soalan pun in detail, must be in detail. Alright, fault occur at P1 and P2. In order for the circuit breaker to open, once this circuit breaker ni to open, okay, sekarang ni dalam solution ni dia cerita start pada circuit breaker. You boleh cerita juga daripada sini fault happen, tapi tak apalah, kita follow dia punya solution. Okay, in order to circuit breaker to open or trip, both relay contact directional and overcurrent must be closed. Yes, betul. Because dia betul series. Kalau series apa jadi? So both relay need to turn on ataupun contact dia turn on. Sebab series, kalau ini on, ini off pun tak guna. Dia akan open circuit. So both must be contact on. Okay. Directional relay are designed to operate for fault current in one direction only. Kita tahulah. Directional relay operating only forward direction, one direction only. Since the line impedance is mostly reactive, a fault at P1 to the right of the CT will have fault current from bus 1 to bus 2 that lag the bus voltage by V an angle of almost 90 degree. This result in maximum positive torque on rotating disc, which would cause the directional relay to close. So this is the explanation there. Tapi you boleh cerita juga kan. Sebenarnya when the fault occur kat sini, what happened, you boleh bagi tahulah. Because you tahu kan, when the fault happen here, so macam bagi tahu you lah, fault current dia akan go through the CT first, later on dia pergi pada fault, so dia akan jadi forward direction. And then you juga boleh tambah lah what happen in the fault direction, the current lags behind the voltage plus 90 degree lah. Okay, so mana-mana you boleh guna. Dalam nota ni dia buat macam ni. Dia cerita pasal reactive tak apa. Okay, ada you faham. Okay, this result in maximum. Yang penting you cerita tentang positive direction, forward direction. So why it's forward direction, you boleh gunakan macam ni. This result in maximum positive torque in rotating disc, which will cause the relay contact to close. Maksudnya when the fault occur kat sini, direction relay ni akan turn on. Kenapa? Because dia forward direction, contact dia akan turn on. Right? If the secondary current of CT exceeds the pickup current, the overcurrent relay contact will close, thus the CB will open. So if the fault from P1 ni exceed the pickup of overcurrent relay, I pickup tadi, I prime exceed the pickup, so contact juga akan turn on. Both turn on. Right? Then what happen when both turn on, circuit breaker akan open, contact akan open untuk isolate the fault from the healthy system, from the equipment. On the other hand, a fault at P2, okay, now P2. What happened P2? P2, cerita sekarang ni dia reverse. Kenapa? Untuk directional, sebab dia fault dulu, barulah pergi go to the CT. Okay. On the other hand, the fault at P2, the left on the CT will have fault current that leads the voltage by almost 90 degree. So condition dia leads the voltage when the reverse direction. Okay. This we have a fault current that lead. Okay, this fault current is said to be in reverse directions. This result in maximum negative torque on the rotating disc, which would cause the directional relay contact to remain open, thus the CB will remain closed. Maksudnya, because of the fault kat sini, directional relay ni sees the fault as the reverse direction, so contact dia akan open. Dia tak akan trigger on the coil. Okay, so what happen? Breaker tak akan turn on, dia akan remain closed. Dia tak akan isolate the fault. Maksudnya kat sini dia boleh differentiate between the fault kat sini and the other one fault here. Itu maksud dia. Okay, this result in maximum torque. Ini ceritalah negative because kita tahu untuk on and off the Konteks sebenarnya dia pakai torque, dia ada disc. Alright, kita panggil rotating disc, which will cause the additional relay contact to remain open, thus the CB will remain closed. Okay. Alright, that is the question number 1A. Question B, if the fault at P1, the secondary side of VT, okay, 400 with angle of 30 degree, and CT 800 amps with angle of minus 60 degree amps, determine the torque. Sekali dia akan cari torque produced in the directional relay. D, explain the operation of both relay, either it will be tripped or not. Okay, soalan ni sebenarnya you kena kira the torque produced by in the directional relay. So what the torque? Torque ni you need to use equation. Letak equation kat sini. Ini dia equation dia. This one yang ini. So we need to apply this equation in order to determine the torque. Dia kenapa torque sebenarnya? Kalau ada tak kat sini dia tak tunjuk. Kita tengok ada ke mana ni. Ada ya? Ada satu slide tu dia tunjukkan phase of nama tu directional relay. Saya tengok kat dulu. Nak disebabkan yang ni. Tadi agak jumpa saya. The slide tu mana ya? Okay, kita cari macam ni later. Alright. Okay, nak cari sebenarnya. Dia konsep sama. Ini ialah differential relay kan. Tapi kita buat ialah apa tu kita panggil directional relay kan. Dan konsep sama. Dia akan ada macam ni juga. Dia perlukan torque force untuk trigger the relay. So untuk this question sebenarnya you kena kira torque dia by using this equation. Is it? Okay, maybe I think saya scroll one by one. Okay, this one right. Okay, right. So this is the voltage VT. Okay, dia bagi tahu dah. This is secondary. So maksudnya V prime, I prime. Okay, determine the torque produced. Okay, equation kita tahu dah. Alright. So if the fault at P1, the secondary side of VT 400 CT 800 angle, this one 30 minus 60, determine the torque produced. Okay, torque produced cerita dia you kena tahu each element kat sini, component kat sini. K berapa, V prime, I prime, sin the angle. Ini apa? Ini ialah the angle. Maksud kita nak tahu angle of voltage minus angle of current. Kat sini nampak theta V minus theta 1. So maksudnya you nak tahu the difference between the angle between the voltage prime and I prime. Ingat kalau V prime I prime maksudnya secondary yang CT dah step down. Okay. Kalau tak ada prime ialah primary fault voltage or fault current. You kena clear on this symbol. Okay. Okay, so that's why here, okay, so we have this formula. So kita tahulah K. Kita go one by one. Alright. K, okay, K, alright, kat sini kalau ikutkan solution, dia cari nilai VT. VT is 400. Straightforward from the questions. 400. CT is 800. Kita just take the magnitude. Okay. K, ini kat atas semua ni just Tak ada apa, it's just equation sebenarnya sebab you boleh use straightforward from the question kat sini. Okay, K is 1 over 2 pi F. 1 over 2 pi F, 2 pi biasalah you tahu 3.142. F frequency 50 Hz. So from here you dapat the value of K is 3.183 times 10 of power of minus 3. So just substitute in these equations. Okay, dan inilah. So we can determine the value of torque produced. Okay, right. VT, CT. VT is 400. So this is 400. CT is 800. 800. Sine. Agreement. VT. VT from here is 30. So 30. 30 minus 60. So dia akan jadi sine 90 degree kat sini. Kan? Ya, betul lah. 30 minus dia akan jadi campur kan, dan 60. So it will have about 90 degrees. So 90 degrees sin 1 . So you dapat nilai torque is 1018.6 Newton meter. Okay. For the P1 forward direction, the current lags the voltage by 90 degree. Kenapa lag? Because dia forward. Balik pada nota tadi lah. Right. This will result in the maximum positive torque of this value on the rotating disc, which would cause the directional relay contact to close. Ingat, kalau torque dia negatif, maksudnya dia reverse. Nanti kita akan jumpa reverse kat sini. On the other hand, the secondary current CT 800 ampere exceed the overcurrent pickup current 500 ampere, which will cause the overcurrent relay to contact to close. Hence, the circuit breaker will open since both of the relay contact are closed. So ingatlah, untuk question overcurrent relay ni, you kena always relate with directional and overcurrent. Okay, directional in this case, you cerita tentang, question ni dicerita tentang torque produced because positive torque. Maximum positive torque produced because the forward direction. The other one, you have to mention what happened to the overcurrent relay. So overcurrent relay is, dalam soalan ni kan, dia bagi tahu dah. Dan from the first question ni, pickup is 500 ampere secondary. So in this question, yang mana yang inilah, secondary is 800 ampere. So dia exceed, dia lebih daripada pickup. So dia akan turn on, both turn on. Satu because of the forward direction, positive torque. The other one is because dia exceeds the pickup 500 ampere, 800. So both akan turn on. Okay, faham Alright, that's why dia breaker akan turn on, because both relay contact are closed. Alright, C. In the fault, if the fault is at P2, the secondary side of VT, okay. So this is the condition when P2. Alright, okay. Determine the torque T produced in the directional relay D. Explain the operation of both relay either is V3 or not. So cerita sekarang ni, kalau kat sini, what happened? Question ni you tahu dah. Sini what happened? So you can imagine, because kat sini cerita dia akan reverse direction of directional relay. Dia reverse. Dan tadi you give positive torque kat sini. So of course kat sini akan jadi negative torque. Itulah idea dia. Dia tak jadi positif. Kalau positif, yang turn on juga. Negative. Okay. So we go to the calculation. Yang sama. Question yang sama yang ini. Alright. Okay. So case value dia tak buat unchanged. Remain 1 over 2 pi F. VT pun sama. CT pun sama. Semua agreement, the angle. Voltage angle minus CT angle. So kat sini nampak voltage angle is 30 minus 120. So dia akan jadi negatif 30 tolak 120 dan minus 120 sorry, minus 90. So dia akan jadi negatif kat sini This is negative 1. Sin negative 90. Inilah negative 1 So you dapat negative. From the result of P2 reverse direction, the current leads the voltage by 90 degree. This will result in maximum negative torque, right, and on the rotating disc, which would cause the directional relay contact to remain open. Dia tak turn on lah, dia remain open, dia tak close. On the other hand, the secondary current CT exceeds the pickup of 500, which would cause the overcurrent relay contact to close. Tapi cerita sekali, because the fault is 800, dia exceeds the pickup 500. But because of the directional relay, they remain open because of the negative torque. So breaker will remain open. Breaker takkan open lah. It remain No, ni salah ni. Remain closed broken breaker ni dia dalam connection dia close dia akan remain closed, dia tak akan open. So betulkan sikit lah dalam nota ni it's not remain open, remain closed. Kalau open daripada awal dia open, tak boleh lah, fault dia dah clear. Since the relay B, contact relay still open. So you faham breaker always remain closed because direction relay dia open. Maksudnya in this condition only overcurrent relay dia close, tapi directional relay dia open sebab fault kat sini. So breaker dia akan remain closed. Dia tak akan clear the fault of P1. Dia akan only clear the fault at P1, not P2. Sorry, this is P2 this is P1. Okay, faham Rasa ulang yang sama, cerita yang sama. I think you all faham lah kan benda ni Alright. So sampai sini okay semua? Ada soalan nak tanya tak? Any questions? Okay, kita boleh pergi pada next one kalau tak ada. Okay ke? Pagi-pagi ni?
Okay, sir.
Dah breakfast dah? Dah
Belum.
Pagi-pagi saya rasa ramai belum lah kan. Kalau yang dah tu bagus. Kelas pukul 8 ni standard lah kelas pukul 8 ni macam-macam hal lah. Sebab tu kadang-kadang kelas awal sangat pun tak bagus juga kan. Sebab itu isu dia. Malam tadi tidur lambat tengok bola pagi-pagi nak bangun tak boleh. Ataupun kelas saya cerita, saya tak nampak you buat apa. Ada buka, ada tidur, ada dengar, ada tak kan. Tapi kalau better you dengar lah better you explanation tu you kena dengar betul-betul because later bila you buat self study, you baca, you dah tahu maksudnya you dah ada ideas apa yang berlaku, so senang untuk you faham. Tapi kalau you tak kelas you tak attend ataupun you tak dengar, you tak give your attention full attention, so masa ceritanya nanti you baca you akan pening apa benda yang nak buat. Ataupun you kena buat lebih kerja lah, you kena baca, you kena buka sana buka sini. Okay, alright. I nak cerita pasal ni differential relay, differential protection tapi I tak dapat nak share masa lagi. I tak tahu kenapa. I try many times to share juga WhatsApp group tapi tak boleh buka juga. Sometimes WhatsApp ni dia ada masalah juga sini. Okay, tak apa, I try sekali lagi. Tak boleh tak apa, I akan share after class. Okay. Alright. Oh, okay. So boleh kot, ada cuba dapat dah. 4G. Okay, I ada share dekat WhatsApp tu, you boleh buka lah sambil I explain sebab susah you nak faham kalau tak ada dengan you lah, sebab I kena scroll up and down, nanti you pening Okay, boleh buka tak? Ada? Cuba tengok WhatsApp group.
Boleh.
Okay good Okay. So open dulu so ini adalah about differential protection so kita tahu back to our note kat sini we have this one so I cover this one, I cover impedance relay ni you boleh refer pada nota, dalam nota pun dah saya kata dah complete pun exercise yang duduk dalam nota tutorial, so you boleh follow the notes okay for impedance. So I just focus on the second one, and the last one is the differential. This is differential Yes, the last release is the differential protection. Okay. Right. A differential protection relay is used to protect single phase transformer bank from the internal faults. Okay. 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 Alright, differential potential relay is used to protect single phase transformer from an internal faults. Okay, the single phase transformer bank has rating 10 MVA, 60 kV, 10 kV. Ini primary secondary tadi. apa tu kita katakan high voltage side, low voltage side. The current transformer given 205 and 1000/5. So ini ialah untuk high voltage side and this is low voltage side. Connected to this HV and LV, high low voltage side of the transformer respectively. So apa question dia? Dalam ni dia tak bagi diagram tak apalah kita buka dalam mesti ada sama je konsep dia. Kita tengok pada not directional, differential. Okay. Is the differential? Lagi lah. Okay. Right, this one differential relay. So differential relay tahu dia ada mismatch of current kita pernah kira sebelum ni. Tapi soalan ni agak basic. Okay, so this is the circuit diagram lah for the questions sama lah. So dia ada dua winding, satu primary ataupun ini untuk generator tapi konsep sama kalau dia letak pada transformer. Dalam soalan ini transformer. So transformer ni you tahulah ada high voltage side biasanya kat sini and low voltage side at this side, low voltage side Okay, so it has two CTs connected at the LV high voltage side and the LV low voltage side. CT1, CT2. So CT1 dia akan step down the primary current kepada I1 prime. CT2 it will step down the secondary current to I2 prime. Okay. Alright. Whenever there mismatch between the currents, dia akan trigger the coil. Okay. And then what happen when the coil contact on, dia akan open the inilah circuit breaker. Okay. Alright. Okay. Back to the question kat sini Okay. So solutions. Okay. CT ratio dibagi yang ini 200/5, 1000/5. Okay. So dekat mana? This is 200/5. This is 1000/5. Alright. Okay, lagi apa kita ada? 60, 10 kV. So this is 60 kV. This is 60 kV. This is 60 kV side and this is 10 kV side. High voltage side, low voltage side. Semua you tak boleh kata ni not generator, this is transformer, different tak sama Tapi because I cuma ada diagram ni, so I guna diagram lah untuk show you, untuk you faham Okay. Alright. Alright, so this is the data from the questions. As rated is transformer dia rated lah 10 MVA, so 10 power of 6 10 times 10 of power of 6 MVA. V1 is 60 primary, secondary voltage. CT ratio this one and CT ratio for second one is this one. Okay, the first question, determine the secondary current of CT I1 prime connected at the HV side of transformer bank. So soalan ini straightforward you nak cari I1 prime. So I1 prime of course I rated as mula you cari dulu the value of I1 ataupun primary current primary current S over V. Kita tahulah kan S over P ataupun PIV ataupun SIV kan. So I is S over V. Ini straightforward equation Okay. So you dapat nilai I1 rated is 166.667. Dekat mana nilai ni? Nilai ni ialah dekat primary current Kalau refer kat sini balik, nilai yang ini primary current. Rated current. Not the step down I1 prime, primary. Macam cakap tadi lah. If dia tak ada prime, maksudnya dia tak tulis prime. Kat sini dia tak buat pakai macam ni, dia tulis prime. Tak apalah, you faham lah. Okay. So I rated is 166.665. So I step down by the CTs. You kena divide by the CT ratio. Kat sini ialah I rated ni divide by this CT ratio. Yang mana yang ini? Then you get the obtain the value of I1 prime 4.167. So dekat mana? Dan ini yang ini bawah ni. 4.167. Dia dah step down. Ingat function ratio dia nak step down the primary current kepada secondary current. Kenapa dia mestilah step down untuk operation. Kalau tak susah lah kan you pakai nilai yang tinggi Okay. Alright. So you have the value of I rated prime. I prime pun tak apalah. Kat sini I rated prime lah. Whatever is kita pakai I1 prime. Sama 4.167 ampere. Okay. Second question. Determine the secondary current I2 prime. Yang mana? This one I2 prime. step down by the second city, right, from the I2. Okay. Alright. At lower side. So sama case dia juga. S bagi V2. S is this one. Bagi dengan divide by the lower side is 10 kilowatt, sorry. So, kilo M lah, sorry kilo. This is watt, yes, kilowatt So, you dapat 1000 ampere. 1000 ampere dekat mana? Dekat sini lah. Again kat sini. This is 1000 ampere. So, step down the currents forward by the CT ratio of C, because we're talking about CT2. So here is 5. So kat sini ialah 5 ampere I2 prime. So faham Dapat nilai ni? Faham kan sama tapi kali kena divide by the CT ratio. Okay.
Kita darab sir.
Sebab dia dah kan, so you kena darab lah. Tapi kalau you tak buat macam ni, you kena bahagilah. I rated divide by CT ratio. Tapi kat sini dia dah, macam mana cakap dia dah directly dah kira kan. Jadi macam ni je, macam ni lah. You kena divide by sepatutnya, tapi sebab dia dah buat macam tu, dia harap lah. Okay. Mana dia? Nak scroll down all the notes yang banyak Dekat kat sini. Ini betul-betul lah. You ambil, you take the voltage lah kan. Nampak dia divide by ratio Dia juga macam ni lah. Okay. Okay. So, okay, sampai sini boleh Okay, calculate the mismatch of the currents for secondary current. So equation yang ni I2 prime minus I divided by I1 prime 0.2. So current ni I2 prime, this one minus this one divided by this one, kita dapat ada mismatch of the currents. Faham equation dia? Equation dia sama macam kita buat tadi mula tadi dalam dia pakai yang sama untuk ni mismatch Kalau nota ni tak ada ke? Tak apalah Saya nak cari satu agak banyak cerita sekarang ni you just pakai ni lah untuk kira mismatch. Okay. Alright, 0.2. Calculate I2 prime at the upper limit blocking. Okay, dalam case ni soalan ni dia agak tricky sikit kenapa sebab you kena pakai slope, you kena pakai ni mana dia? Directional. Kita balik kat directional. Ingat operation of direction relay ni basically dia akan this one dia ada operator case one. Sebenarnya soalan ni dia based pada soalan ni. Pada figure ni dia ada upper bound, lower bound, dia ada block region. So cerita sekarang ni dia ada satu in order to relay to operate, satu dia mesti kalau upper bound dia mesti higher than this inilah region baru dia turn on. Kalau lower bound dia mesti less. Kalau dia tak ada in the middle ataupun dia less than minimum. Okay, tak apa. Tapi cerita sekarang ni you need to understand this diagram lah, right? So relationship between I1 prime and I2 prime. Okay, sebab kita tak tahu mismatch Okay, so equation dia macam ni. Kalau ada upper bound 2 plus k divide by 2 minus k, lower bound 2 minus k divide by 2 plus k. Dan soalan ni bagi k 0.1 dalam case ni, tapi dalam soalan yang k is not be given. You need to calculate the value of k, right? Okay, so sampai sini faham? Okay, calculate I2 prime at the upper limit blocking region. So kat mana? Upper limit atas ni lah. This is lower limit and this is upper limit. Okay, okay, upper slope 1 plus mismatch. Okay, dalam equation ni
Good
Any
luck.
question to determine
Thanks
the
for
value
that
of
tip. It seems like
upper
there are a
slope.
couple
Slope
pressure
ni tahu
pads here
kan?
which we're gonna have to step
Okay,
on in order
macam
to make
Y
our
sama
way to
MX. M ni kita panggil
Sabrina.
apa
I'm gonna go ahead and unclick my
Slope
running
lah,
shoes
ataupun kita
because I
kata
don't think it'll be a good
apa tu,
idea to
keturunan.
run around here. Look at
Itulah
Grandma over here
dalam
staring.
bahasa Melayu. Y MX. M berapa So slope is
Now, I'm gonna try my best
one
to
equation
avoid
dia
as
1 tambah
many trainers
mismatch
as possible.
So
I
1
don't know if it'll
plus
happen, but
0.2 you dapat 1.20. Okay, so inilah dia punya slope. Ya, slope untuk
I guess we'll figure it out
this.
along the way.
Apa?
We'll see how long it takes for me to act.
Upper bound, lower bound, this one. Okay, back to this question. So because the value of
Actually
upper
get
slope
to
is
this lady.
1.20,
I don't really know
so we can
how
obtain
to
the value
get
of
there
K
completely,
by
so it's gonna
simplify
be a
this
lot of
equation,
guessing checking.
which is K
And
is
of course, we bumped into a battle
0.1816.
already. It's good. It's a little bit of
Okay.
warm up. We got this.
Alright, so from this I2 rated prime,
Turn
upper slope I
no
rated
trouble.
prime,
Trouble from this
ataupun
guy. Let's just keep running around
Y
here.
equivalent
We'll
to
eventually figure out how to get to
MX
Sabrina.
from the
No
linear
trouble.
graph.
You know, we're in
So
no
we can
hurry here
obtain the value
whatsoever.
of
Turn around.
I2 rated prime
Sabrina,
upper
no trouble.
limit.
Good. No more trouble from this guy. Let's just
5
keep running
ampere.
whatsoever.
So dapat.
Turn around. Turn around.
Kita sekarang ni,
Don't look at me with your Bieber haircuts.
dalam ni,
Alright, let's go ahead and this.
I kena scroll down Okay, kat sini okay. Alright. Sekarang ni kita nak guna this
Portal, and did we? No,
graph
we made it
in
back to
order to
another
determine
grandma.
the I2
There sure
prime.
are a lot of grandmas in this game, and there we.
Untuk dapatkan apa? Untuk dapatkan the upper limit. Limit dia, for the condition of berapa nilai I1 prime. Okay. From the first calculation, our I1 prime is 4.167. Daripada soalan ni, tadi kan ingat ada kita kira tadi. Dia kata determine the second track current. So nilai I prime is 4.17 67 sorry. 4.167. Okay. Benda ni agak confusing. Okay. Mana dia? Alright. Yang ini So kita kira tadi yang ini dan kita juga kira yang ni. Kamu what's the upper limit based on the value prime upper limit. Okay? Apa nilai dia? For the condition of amount dia berapa? Value berapa? Value dia ialah this one. 4.167. Okay. So from the graph ni equation relationship of y sama mx so we can obtain the value of I prime upper limit, okay, upper slope times the I rated prime is equivalent to 5 ampere. So kalau you tengok kat sini, so 4.167 from the first calculation, so you just okay, then you dapat nilai 5 ampere kat sini you boleh substitute lah the value of this upper slope time rated, you dapat 5 ampere. Okay, right. So this is the upper limit blocking region, and then second one is lower limit blocking region. Okay, so lower slope. Okay, what is lower slope? This one 2 minus k plus 2 plus k, and 2 divide 2 plus k. K kita tahu nilai dia berapa tadi? K is this one. So slope is 0.833 by substituting this k. Substitute this k, you dapat 0.833. Okay, now you dapat nilai I rated for lower limit, lower slope times the I rated prime, 3.472. So you dapat nilai 3.7 for 3.472 this one. Untuk this current so dia ada dua kat sini. Kat sini dia ada banyak ni sebab dia dah combine dengan soalan nombor yang ni. So tak lagi ni, sebenarnya tidak. Kita cuma tebak dulu. So you ada satu lower limit and you ada satu upper limit. So cerita sekali mesti higher than this or lower than this, dia akan trigger. Faham Okay, so we have the upper limit blocking range, lower limit blocking region for the condition rated prime 4.17. Right. So last question, soalan akhir sekali. Sampai sini boleh faham Sahabat saya scroll down, saya cerita, I cerita kat you. Faham Tengok betul Ya. Okay faham Okay, faham tak apa. Tak faham boleh tanya, tak masalah. Alright. Kita tengok pada last question. Okay, ini soalan dia. An internal fault occur at transformer banks, therefore, ada fault. The 167 is flowing at the HV side of transformer bank and 450 is flowing at the LV side of transformer. Calculate the value of I1 prime and I2 prime. What will happen to the differential protection relay? Okay, sekarang ni fault occurs. Fault occur with this value for both sides. Side high voltage is 450 amp. Lower voltage is, this is high voltage and this is lower voltage. High voltage 167 amp. Lower voltage is 450 amp. Flowing Dia ada fault lah kan, dia ada fault. Okay, fault kat sini high, low, 450. This is what this is okay. Alright. What happened to relay? Here, I thought 167 is 50 amps. You look here for primary, I thought prime, I prime. Maksudnya this equal to the secondary. So this is the amount for 2.25. Okay, kita ni juga ikutkan solution ni dia kira mid and upper limit. Macam so for this condition, for this one, we try to determine the lower limit dulu. Okay, lower slope times the I fault prime, that is this one. This one. Okay, but 9. So 3479 3479. Untuk condition ini ini soalan kan 475. So this is this ni. Alright, and then to determine the first slope. For 1 so mana you time for prime I1 prime dah ini you dapat 4 okay. Now kita soalan ni calculate dan new. Okay, kita calculate kat sini. We have the differential potential. Apa akan jadi? The delay which due to the internal because the secondary is 5 is below than the lower limit of 3-pin region 3.479. Okay. Yeah. Because dia akan trick because dia berada tu. Ingat type of apa tu difference relay ni, dia kalau mesti kat sini dia bawah pada tema. Sekarang calculation we can 2.24 dan 347. So kat inilah dia kat bawah dah. So this is the point occur which is lower than this lower limit. So the relay should be turned on. Dia akan trigger. Kalau kita dapat kat sini no, ataupun sama juga kalau dia apa dia pun tak boleh. Okay. So dia punya trigger. Okay. Relay will trigger, right? Trigger because location of the internal fault for that bawah region, I prime at the upper limit region, obtain in the V1 of the level and concept to use kita tekan this diagram relationship between I1 prime and I2 prime for the differential rate. We complete for to taken tutorial. Okay, sekarang sini ada soalan tanya? Ada pukul 10 dah. Any question to ada apa nak cakap? Faham tengah berfikir lagi. Saya tengok pada tu nak room Oh, you have device. So ada meeting orang Okay. Since majority ada kan, saya nak beritahu second test mungkin saya buat Jumaat depan dia akan cover symmetrical fault, unsymmetrical fault dengan protection So you kena study lah. Okay. So this time buat betul-betul untuk second test. Kalau you rasa test 1 you tu okay ataupun tak okay, so make sure you jawab soalan You have to answer the question dan jangan kata you tak jawab lepas tu you tinggal kosong jangan macam tu Untuk final pun jangan buat macam tu. Kalau tak you dapat kosong lah. Itu masalah dia. Bukanlah kata you jawab main jawab tidak I akan tengok juga. Tapi tu saya cakap kalau you attend kelas lalu tutorial you hantar kan you ada effort I cuba bantulah sebab kadang-kadang soalan final ni kita tak boleh nak predict juga kadang-kadang soalan yang sukar, soalan yang senang sebab macam tu lah. Tapi semasa you ambil kelas tu you buat tak assignment, you hantar tak test ataupun you attend tak kelas, so semua tu I akan tengok lah. Memang bukan saja semua lecturer macam tu dia akan tengok commitment of the student okay, itu yang penting. Sebenarnya belajar ni bukan setakat you nak lulus atau gagal. This is how ni juga you nak orang kata develop diri you lah untuk lagi disiplin kan. Okay, benda-benda macam tu penting kita kata yang tersirat dan tersurat lah kan. Yang tersurat you nak ambil exam, you nak test, you nak grade, tapi the process you nak sampai ke tahap you grade tu, you habis belajar tu you kena belajar how to be a good engineer okay, kena on time kelas, on time datang, jangan lambat. Semua tu penting Kenapa? Because this is where you develop yourself you nak develop daripada awal untuk jadi kata your future lah untuk engineer yang baik lah kan. Kalau you kerja you dah terlambat kelas semua ataupun you dah kerja you dah terlambat di office semua masalah nanti. Benda tu kena start from university level lagi lah. Okay, alright, I think setakat itu saja. Tak ada apa kan nak tanya kan? Semua okay?
Tiada.
Semua okay lah. Okay, kalau semua okay, that's all I rasa nak sampai pada you all semua. Itu on kamera okay, mungkin setakat itu dulu untuk hari ni. Right, okay, thank you very much everybody, take care. Right, so kita jumpa balik hari Jumaat.